Once again, welcome. I like to start a lot of my presentations by providing context on why we're doing this, and also to try and provide a baseline on what we mean by connectivity. So I think it's no surprise to anyone in here that there is a rapid and significant growth in terms of the infrastructure, and despite many of these rapid enhancements, we're actually seeing resilience challenges across different parts of the continent. We're also seeing performance challenges. There are a range of solutions people are proposing. These solutions go from localization of content to addition of terrestrial connectivity, and across all of these there is a question of how do you fund them, which ones do you fund, and that's a lot of where we're going to be coming from. When I say the internet ecosystem, what I essentially mean is what are the different components that a person needs to engage with to connect to a web service. So if you want to go and use your favorite web service, my favorite web service is, I'm pretty old, so it's still facebook.com. You have to go over a set of terrestrial fibers and connect, hopefully at an IX, to some content servers. And depending on what you're trying to get, you might need to go from that content server all the way back to the origin or data center via some submarine cables to fetch data. So when you're thinking about what happens when I'm trying to browse a web page, what happens when I'm trying to engage in a video call, there is a mix of terrestrial, submarine, if you're lucky, IXs, if you're unlucky, just purely data center and clouds. And in this talk, what we're going to focus on is on analyzing investments in IX and submarine cables. So I think you go far back last decade, most of what you've seen has been in these two areas. The last 3 years, we've seen a lot more in the data center space. So in a couple of years, when I come back and give a similar presentation, we will be looking at data centers. Probably we'll also be looking at LEO satellites and Starlink. But for today, we will focus on IX and submarine cables. If you were here an hour ago, you saw Patrick's presentation, so you know that there's a lot of fiber here, a lot of submarine fiber. I'm not going to go through this in a lot of detail because he's given an amazing presentation, but from his presentation, you also saw that over time, it's gotten a lot better. And if you go and you look at his maps with the newer cloud data center maps, you will also start to see something similar where the number of IXs have grown. Here we have data from AF-CIX where you see over the last 7 years a huge growth in terms of active IXs. A lot of what I'll talk about when I analyze improvements, I will use one example, but this example is representative of a lot of other cables you'll see out there. In particular, I'll use the AF-CIX cable. And this was a cable that was deployed in 2018. We have some other data that I will briefly show with, I believe, to Africa and Ecuador, but a lot of the examples will be from this very simple deployment. This is based on a lot of measurement data, and the measurement data we've used has been from RIPE Atlas project in Netherlands and the KIDA ARC project from California, where they have deployed a large set of measurement devices across the world. And we've been looking at over approximately 2 million of these trace routes and approximately 8 million DNS requests. And doing this analysis, we looked at roughly 9 submarine cable deployments over the last 7 or 8 years. And we looked at almost 80 IXP deployments in roughly 32 countries. So a lot of this is backed by the data that these entities have been collecting over time. And one of the things I will do at the end is try to argue that we should be deploying more for more measurement studies. In terms of the other data sets that we've used to complement and understand the trace routes, obviously we use telegeography data set, we use PRNDB, and then we use data that I've talked about previously. But a lot of the telegeography, the PRNDB data set is to understand what is going on. The trace routes are actually what give us the performance measurements that we're going to analyze. Looking at submarine cables, there are essentially two questions we have. The first kind of broad question is, when do you get benefits? And when you are getting these benefits, do these benefits translate to your neighboring countries? And I think kind of coming into this conversation, the answer is quite obvious. The answer is basically more or less there will be some benefit. The question is to what extent, how much is the benefit? And when you look at the neighboring ecosystem, the kind of obvious answer there is it depends. And our approach here is to understand what does it depend on. So the first result we have here is basically looking at performance. This is looking at RTTs. I think there is a limitation here in that while we're looking at raw network numbers, it doesn't translate to application level metrics. So one of our future goals is to also look at this from the application perspective. But for today, a lot of what we will look at is what are the RTT improvements that you see with these deployments. So from a network level perspective, what performance improvements are you essentially observing? For our study, the way we look at this is from telegeography, we understand when a deployment was ready for service. From PRNDB, we know roughly when pairs are added to an IX. So we look at 3 months before this activation and 3 months after, and essentially try to understand the performance change, aggregate performance change before and after this deployment, whereas the deployment could be submarine cables or it could be pairing at IX. And looking at the submarine cables themselves, one of the things that we observe is that on average there is roughly 12%, and a majority of the trace routes are seeing basically 20% improvement. At the very extreme, you will end up seeing that there are some locations where you see as much as 80% improvement. And naturally, there's a question here. When do you see low improvement? When do you see a much larger improvement? So the next analysis that we try to do is to figure out what are some of the conditions that can lead to a higher return on investment. There is a paper that we have that has a whole bunch of analysis. I've been told I only have 20 minutes and an extra 20 minutes because we're in Africa, so I will only talk about a small set of the story. I'll be on time. I will only talk about a few of this analysis. So one of the analysis that we were looking at is you look at submarine cables. When they come in, there is already connectivity in the country. Oftentimes the connectivity is indirect. For example, Angola to Brazil might go through South Africa before AF-CIX came in. After AF-CIX came in, it's a more direct Angola to Brazil. So we label this an indirect connection, translate into a direct connection. And when we look at all of the cables that we were analyzing, one of the things we try to identify is for each cable and for the pairs of landing points for the cable, what is the benefit from direct to direct, indirect to direct, indirect to indirect. And I have 3 representative results here. And you'll see across all of these that essentially when you go from indirect to direct, you will kind of always have a better improvement. When you look at direct to direct or indirect to indirect, you see kind of varying amounts of improvements. Across the whole data set, obviously the indirect to direct has the highest improvement. We see on average about 32% improvement. This is what you would expect because you're no longer going through an intermediate country. You're now directly connected to the other end. So this improvement is what we expect. This is what essentially people think of when you're essentially saying, okay, we're going from an indirect route to a direct route. When we look at countries where they already had a direct connection, we still see an improvement, but we see a smaller improvement. And I think one thing to point out here is while we only see a small improvement, there is a huge benefit to these redundant cables. Resilience. Last year's cable cuts, if we had more of these redundant cables more spread out, we would have been able to get around them. So while from a performance perspective, direct to direct doesn't provide as large a benefit as indirect to direct, the direct to direct is still crucial from a resilient perspective. And indirect to indirect is quite small, and I will not discuss this in detail, but we can talk about it over lunch. The other thing we looked at is what is the impact for neighboring countries, and here the question is, how much extra traffic do you see as a neighbor of a country deploying and getting a new cable, and does it improve your performance as well? And the answers to both of these are yes, and roughly it depends what you're going to see. This is the peace cable, and the country in red, orange, or pink, whatever it looks like over there, is the one that's getting the landing point. And as you can see, a lot of the neighboring countries see higher transit going through the target. The ratios change. West Africa, Central Africa, some of those countries having a higher transit through this country than others. And looking at RTT improvements for AF-CIX, you also see that for the neighboring countries, there's also a noticeable improvement. A lot of this improvement has to do with kind of the market maturity of these individual countries. I won't be able to discuss this in a whole lot of detail, but once again, we have more results that we can talk about offline. Switching over to peering, one of the key things here is basically trying to understand when a new AF-CIX provides benefit and what are the conditions that impact these benefits. And here, as with before, we're going to look at RTTs. One difference here is that we're also going to look at the DNS servers that are getting deployed at this AF-CIX. So we'll look at how does an AF-CIX deployment improve or change your performance profile. And once again, its performance profile here is latency. And then we'll look at it from a slightly higher level in terms of DNS. So here there is basically a graph that shows improvements for the different AF-CIXs. And once again here you see that very clearly there is basically generally always an improvement. The improvement varies. On one hand, you see Ghana where the RTT improvement is basically 150%. On the very, very end, you see places like AF-CIX where it's much, much lower. You see some of those in South Africa where it's also much lower. Across all of these, one of the things we did notice is that there is, going back to Patrick's presentation earlier, these AF-CIX do change the dependence on Europe. I think the second presentation will talk about this in more detail, but you look at the AF-CIX deployment, regardless of the performance you get from it, you also do notice that there is a lower transit through Europe. It's still not at the case where it's completely eliminating it yet, but you do observe that lower transit, that higher localization of data. And trying to understand when you get benefits, we looked at several conditions. One of the conditions we looked at is inter-country. AF-CIX is formed and an AS is becoming a member. If both of these are in two separate countries, what is the benefit? If both of these are in the same country, what is the benefit that we see? And one of the kind of interesting things, especially for the students, which kind of surprised them a lot, is when you look at this, going outside to an AF-CIX in a neighboring country provides you a large benefit versus going to an AF-CIX in your country. And I think there's a huge caveat with this result that I will talk probably will not talk about. But there's a caveat with this result. But in aggregate, when you're going to an AS, when you're an AS joining an IX outside of your country, you get a bigger benefit, and this depends on the kind of traffic and content you're essentially going to. If you're an AS connecting to an IX in your country, you get a lower benefit in terms of this RTT, but I'm going to jump ahead. Because that's, all right, so jumping ahead to the caveat. One of the kind of caveats is content placement. So if the IX you're joining in your country essentially has DNS servers and content servers that you're using, then you actually do notice a much better improvement. So this is data from the DNS analysis. When you're connecting to an IX in your country, looking at the DNS analysis, you actually see significant improvements. If you're connecting outside of your country, looking at a DNS analysis, you get a lower improvement. And this is kind of a bit obvious in that because the IX is in your country and you're going to DNS, latency is going to be lower. If it's an IX outside of your country and you're going to DNS, latencies will be higher. So when you're connecting to an IX, there is a key thing to try to think about in terms of what kind of content servers are there, what kind of content is local there, because that impacts the traffic. But also if you're using the IX for traffic going to non-content servers, then having that connectivity bridging you across the continent, the region, provides a benefit. Going back now, it's not time. Going back, looking at the RTT the analysis, one of the things we kind of observed is better performance across all of the DNS services. The key ones that had like a very huge improvement was Cloudflare, and I suspect this has something to do with how they use Anycast. And then the ISP resolvers provide the second benefit. But I think the key thing here is across all of these, you will see some benefit, and what impacts the exact benefits changes based on what they're doing for routing and targeting. So kind of jumping ahead, one of the key findings is there is tangible, quantifiable benefits, and these benefits change from region to region. There is a huge correlation between the benefits and the domestic infrastructure. So looking at a country's GDP, you can actually see a correlation between what kind of benefits you expect and what you get from deployments. And this also translates into the neighboring regions. So when you're looking at these cable deployments, there are a bunch of other factors that you can try to quantify to understand the return. Looking at the IX perspective, once again, there is improvements, and we see larger improvements in developing regions. So one of the things I didn't get time to talk about is if you look at ASs joining an IX, if this is your first pair, you have significant, if this is the first time an AS is joining an IX, you have significant improvements. If this is an AS joining its fifth IX, you have diminishing returns. You still have, in all of these cases, you still have performance improvements. It's just you kind of get to see diminishing returns. And one of the things we found interesting is in terms of the relationship between IX membership and DNS performance improvements. And we suspect if we start to look at higher level applications, you will also start to see a parallel between what we see in DNS. And I know I'm more or less out of time, so there are a bunch of recommendations. There's the ongoing recommendation to try and find ways to fund more of these IXs, perhaps using some of these UFC funds. There is one of the things that I'm passionate about, trying to get more measurement probes out there, RIPE Atlas probes and some Raspberry Pis that we have. And as everyone has been saying, we need to look into more terrestrial connectivity. And in terms of our next steps, there is the very obvious looking at resilience. We focused solely on performance, but performance is not the whole story. So how do we look at resilience? And the obvious elephant in the room, and I'm sure someone would have asked the question, but is how do we look at Starlink and LEO satellites? And with that, I will end with our contact information.